So let's talk about partitioning now. So let's say we have an S3 folder wherein we have our data files and we store multiple data files either in Parquet format, ORC format or CSV, etc. Let's say each file is of size 200 GB and of course we have Athena on top of it. And let's say we run this query, select customer ID, name and other columns from customers where country equal to India. It will be sent to Athena. Athena will fetch the records and send it back to the client. Now there's a question for you. What do you think how much data would be scanned in this case? So how do you see the data scanned? So whenever you execute a query, we have this data scanned here. It will tell you how much data has been scanned for this particular query. And also next to data scanned, it will show you the execution time. So here in this case, it took 5.5 seconds and this is the time in queue. Again, I'll talk about the query stats, query results, etc. But this is where you can see the data scan. Now the question for you is, for this particular use case, for this particular query, what do you think would be the amount of data scanned? Please pause the video and you can answer it yourself. So the data scan would be 600 GB, even though we are getting records only for country India. Partitioning and bucketing solves this exact problem. So we do not need to scan the entire folder or all the files just to get a subset of record. So that's what partitioning and bucketing does. These are used to reduce the amount of data scanned in Athena. So whenever we do partitioning, we partition the files based on a certain column, and when we pass that column in the where condition, the amount of data scan would be reduced. Let me just extend it. So now let's say we have the S3 folder, and inside of this S3 folder we have 4 subfolders: country equal to India, country equal to France, country equal to USA, and country equal to Russia. And now that 600 GB of files is divided into 150 GB each, considering idealistic scenario. So each country has 150 GB of data. So now again we have Athena. We run this exact same query. It will be sent to Athena and then it will be sent to these subfolders and the results would be returned. Now what do you think the amount of data scanned would be? It would be 150 GB only. Now because what we have done here is that we have partitioned the data set country wise and we have put the country equal to India partition separately, which has only 150 GB of records or data. And now whenever we run the query and mention the partition column in the statement, it would go and get only from that particular partition, which is country equal to India. If you mention country equal to USA, it would go to this particular subfolder and scan this entire 150 GB of data. Of course, if the amount of data scan is reduced, then the query would be faster also. And this is how we create a partition table, create table. We mention the partition by clause, and after that we mention the column followed by is data type. Of course, we can partition by multiple columns, let's say country, then state, and then zip code, etc. And after that the remaining things are same, like stored as, Parquet, and then location, etc. But what happens is that whenever we create this table and mention partition by, the partitions are not captured in the Glue data catalog. So to do that, we have to run something called MSCK repair table followed by the table name. So after we run this, the partitions should be captured and would be there in the Glue data catalog. Why this is important? Because remember that Athena uses Glue data catalog for metadata information. So it gets the partition information and other stuff. So if the partition information is not updated in Glue data catalog, Athena cannot go and hit only one partition. It will have to go and hit all the partitions, right? So make sure to run this command after you create a partition table. Then we can add partitions also. For example, alter table customers, add partition followed by partition name and its value. And it's a best practice to run the MSCK repair table command again. What it does, it again updates the Glue data catalog. Then bucketing is a little different. It's not similar to partitioning. What happens again, we create the table and we mention this keyword clustered by, followed by the column name, and based on which the bucketing would be done, and then we mention the number of buckets. Here I have mentioned 4 buckets. So what would happen is that whenever the record is stored, the value of the bucketed column, in this case customer ID, would be taken into consideration. It would be hashed and put in one of the buckets. How many buckets would be there? Of course, four buckets, because we have mentioned 4 buckets here. Again, let's say we have this customers folder and we can create multiple buckets. It will be done by Athena. We do not have to do anything. We cannot create bucket ourselves and then upload data there. It has to be done by Athena. And it is again further optimization to reduce the data scan, and the buckets are created automatically by Athena. And if you want to do the pruning, let's say you want to use or hit a particular bucket, we have to provide the bucket key in the where clause. So in this case, for this particular table, whenever we query and let's say we want to make sure that Athena only scans one bucket, which would contain the data actually, then we'll have to mention the column based on which the table has been clustered or bucketed. In this case, customer ID. And we can use partitioning and bucketing together. So let's say these are the partitions that we have, and each partition will have their own bucket. So country India would have 4 buckets, country France would have 4 buckets, country USA and Russia would have 4 buckets. So let's do some hands-on. We'll be creating partition tables and cluster tables also. And then I'll tell you about these additional DDL statements which we did not discuss earlier. Before talking about partitioning and bucketing, let me show you the data sets and the folder structure, because that is important. So I have this Athena customers partitioned by country folder. So this is the folder that I have created, Athena customers partitioned by country, and inside of it I have 3 subfolders, wherein country equal to France, then country equal to India, and then country equal to Russia. Now if I click on this particular folder, I have this customer underscore France, which contains customer records from France. Then we have country equal to India, wherein we have customer records from India, and then country equal to Russia, wherein we have customer records from country Russia. And this is very important. So whenever you are creating a partitioned table, and let's say the partitioning is by a certain column, so in this case country column, so we'll have to mention country equal to France. Let's say there are multiple columns, country equal to France, and then we have state also. So inside of this, we'll have to create multiple states also. Now let me create the table. I'll not type it. Let me pause the video and come back when the entire typing is done. Okay, so this is the statement. So create external table customers partition, customer ID name. I have the country also here column. So there would be some problem, but I just wanted to show you. So you have this country column here, and then you have partition by country also. Row format is OpenCSV Survey, and then the separator character, escape character, etc. And if you see the location, I have not given the location of the subfolders. I have given the location of the folder, the entire folder. Basically, this particular folder, Athena customers partition by country, because inside of this I have the subfolders. So I have not provided the subfolders, it's the folder only. Now if I execute this, it should give me error. Okay, so it says failed semantic exception, which is basically a syntax error. And it says the column repeated in partitioning columns. What is meant by that? So it means that the partitioning column, which is country, it is there in the table definition also, and in the partition by clause also. And we cannot do that. If we mention the column in the partition by clause, it cannot be there in the table definition. It cannot be a column in the table definition. But the problem is that the data files that we have, there we have country, right? So now if I, let's say, remove it and now create the table would be created. Okay, so the partitioning information has not been updated. So that's why I do not see any results, but there's no record. So here, let me go back to iceberg part bucket. So this is the table customers underscore partitioned Click on this. This is the schema and this is the partitioning column. So see, partitioning column is here, but if you see, there are no partitions. I cannot see any partitions here. So what we have to do, we'll have to run the msck command, right? So msck repair table. So now if I run this, the execution is done. So 3 partition got added. And if I go to the table details and if I refresh, it should show me all the 3 partitions: country Russia, India and France. So now, as you can see, there are records and it is coming from country India, and I can actually, so if you see here, the data scanned is 100 MB and the runtime was 3.74 seconds. Now let's say if I mention the country, now we are seeing some error. So it should not be an error, right? Because I mentioned the country France and it says that it mismatched input, etc., etc. Now what can be the problem? So the problem here is that the table definition is this, right? And when we ran a select star, it just went ahead and got the rows from that particular table. But in this case, I mentioned country equal to France. And there are partitions as per country equal to France. We have created a partition table on the country code. Now it is Athena is trying to go and get inside of this particular folder, and it is creating problem. Why? Because we have data inside of those folders. What will I do now? I'll have to keep the country code here. Otherwise, there would be problem. So I'll drop the table now. And now I will have to create the table definition as per the data. So I'll mention dummy underscore country here. So which is not the same column name as the country code. And now if I execute this particular statement, which is done, and of course I'll have to run the msck repair, and partitions have been added. And now if I run country equal to France, it should not give me any error. So as you can see, I'll be able to see the records from country only France, right? Okay, so this is what partitioning is. And one more thing is that how do you add partitions? So there were 4 countries in my data file. So let me add a partition also in this particular table. So now I'm altering this table, alter table customer followed by add partition. I'm just mentioning the partition name, country equal to USA. So it has been completed, and now what I have to do is that I will have to create a folder named country equal to USA and then upload the data here. So the file has been uploaded, and now if I, let's say, mention country equal to USA, then I should be able to see the records which should be retrieved from the folder with country. In this case, it is dummy country. So if you see, it is all USA, right? Now, one more thing is that what is the advantage? We have not seen the advantage yet, right? Now, what will I do is, let me run a select star on a non-partition table. So I'll be creating a non-partition table on the same data. So here I have one more folder in the 3IAM Athena dataset, which is Athena customers non-partitioned. So inside of this, I have these 4 files: customer France, customer India, customer Russia, and customer USA. I'll be creating a table with this particular location, and that table will not have any partitioning. So this is the non-partition table, and let me go ahead and create this. No MSCK or anything is needed. And now let me run 2 queries. One is select star from customers underscore non-partition where country equal to India. And I'll do the same on the partitioned table. Right, so it's the exact same query. So this is on the non-partitioned table. Let's look at the data scanned and the runtime or the execution time. So in the first case, 133 MB of data has been scanned and the runtime was 2.4 seconds, which is the non-partitioned table. And now let's do the same on the partitioned table. So the data scanned is only 33.5 megabytes and it took only 2.2 seconds. Let's do the same for another country, let's say USA. On the non-partitioned table, data scanned is again 133 MB and it is 2.3 seconds, and this is 33 MB and 1.7 seconds. So the time taken is less. You don't perceive it to be substantial, but imagine we have hundreds of GBs of data, then definitely this would matter. The partitioned and non-partitioned table would matter. Now let's go ahead and create a bucketed table, but before that what I have done, I have created a folder named customer underscore clustered, and it does not have any object as such. So what I'm going to do is that I'm going to create this particular bucketed table, and I'll select the records from the non-partition table and then insert into this bucketed table. And this is one of the ways of creating bucket table. So few things here is that, let's say I create the or mention the clustered by after the row format survey. And now if I execute this command, so it will give me error saying that some error, input mismatched in input external. So you'll have to remember that to follow the exact syntax. So you'll have to mention the clustered by before the row format survey, which is CSV. So what I'm doing here is that I'm creating this table and I'm bucketing by customer ID into 4 buckets. And of course the survey is CSV and this is the location. I execute this command and this is done. Now I can go ahead and insert. Now let's see whether I can actually insert or not. So if I try to insert from, let's say, the non-partitioned table, it would give error that insert is not supported for bucketed tables, which means that we cannot create a bucketed table using the insert statement. So what we have to do is that we'll have to use CTAS or create table as select. Now I'll go ahead and drop this table, and then I will create the bucketed table using create table as select statement. And this is the syntax: create table customers underscore bucketed with bucketed by is important because we are mentioning array customer ID and we are mentioning the bucket count, let's say, to be 6, and this is the external location as select star from customers non-partitioned. So let me go ahead and execute this. So it scanned approximately 133 MB of data. It took 7.4 seconds and it created the bucketed table in this particular location, customer underscore clustered. Now if I go back to the location customer underscore clustered, I should be able to see 6 files rather. So if you see, I have 6 objects here and all of them are nothing but buckets. So these are 6 different buckets. Why 6 buckets? Because while creating the table, I mentioned the bucket count to be 6. Now what is the advantage? Let me run this select statement for this customer. I'm mentioning the customer ID from the non-partition table. So let's see how long does it take. So it scanned 133 MB of data and it took 1.2 seconds or 1.3 seconds from the non-partition table. So let's take a look at the partition table. Now remember, the table is partitioned on country column, but we are mentioning customer ID in the where clause. So the partitioning table would also not make any difference. So actually you did not get any records. I think the partitioning table is actually empty. So that's fine. Now if I run it in the bucketed table, sorry, it's bucketed. Let's see how long does it take. So it took only 721 milliseconds to get these 2 customers and the data scan was 7 MB. So instead of 133 megabytes, it has scanned only 7 megabytes and it took less than 1 second. So approximately half the time. Again, the difference might not look substantial here because the record sizes are not that big. But imagine that your data size is pretty big. Of course, that will make a huge difference or huge impact when we create or use a bucketed table. And one very important thing is that if you are using bucketed table, you have to mention the bucket or the clustered by column in the where clause to get the benefit of the bucket table.